Find the Fourier series of ax plus b on the interval negative L to L. Now we're only going to find the Fourier series of ax only for now, and then add the b later. Since f of x equals to ax is an odd function, all the a-n coefficients are 0, and the b-n coefficient, using the formula, we have the following, but because x is an odd function and sine is also an odd function, and odd times odd is an even function, integrating an even function, you can integrate instead from 0 to L and double the integral. Now you have this integration. Let's focus on this part of the integral only, and I choose to do it with the tabular integration. If you don't know tabular integration, there's a separate video on my channel. Please watch it. You choose something to differentiate, something to integrate. The derivative of x is 1, and then the 1's derivative is 0. When you get 0, you stop. And then you take the integration column, you integrate. Sine integrates to negative cosine. The coefficient of n pi over L, you take the reciprocal and put it in front of it, so you get L over n pi with a negative cosine. Now integrating this yet again, you get negative sine, but because another reciprocal of this comes in front, you end up with L squared over n squared pi squared. The first column here, it just alternates the plus and minuses starting from plus, so you fill them in, and now you just do this arrow thing across and slightly diagonal down, and you multiply these things. So when you multiply this and when you multiply this, the resulting integral is this. Now then we have to plug in L and 0 into x's. Let's see what we get if we plug them in. So this is what we get if we just plug in L, and you can see that L cancels, L cancels, so you get cosine n pi, sine n pi. Also 0 times anything is 0, so that's just 0, and sine 0 is 0, so that's 0. So this second part is entirely 0, and you only get this part as possibly non-zero, but let's write down. Okay, there's something there that's very important for you to memorize, is the fact that cosine n pi is equal to negative 1 to the nth power, and sine n pi is 0. It's so important that you should memorize this. So using that, we now see that the integral value is negative L squared over n pi times negative 1 to the nth power. So that's the result for the integral. Now we're going to replace this part by this integral value. Then L squared divided by L is just L on top. So we can simplify like this. And once you have all the bn's, and we also know that an is 0, then we can write down the Fourier series for ax, which is this series on the right. Okay. And then what about b? Well, for b, we can just simply add both sides. Whenever you have a constant, you can just ignore it for a while and then add both sides. It still works. Now, if you're curious to know what would have happened if you just started with ax plus b and computed a0 and an, you'll see that an's will all be 0, but a0 will be 2b. So in fact, this b is 2b over 2. This could be the way that some people like to write down the Fourier series. Okay, so this is the formula in general, and it's very handy because if you are doing a homework on Fourier series and it looks like something x plus something with some arbitrary interval, then you can just quickly check whether you did it right or wrong by using this integration. Okay, now so I have a question for you. What do you think the Fourier series of this would be? Now it's more general, now it includes the x squared term. For this, you just have to find the Fourier series of x squared, and then you can use the result that we just figured out here, and you should be able to get the answer. Good luck!